Alright, YouTube, here's the deal. I haven't recorded a video in a very long time because I had a shitty microphone, but I'm back, bitches! And I'm going to try to talk about this ridiculous thing that I've been programming that you can kind of see is on the screen right now because I slightly have it working. I have with me here my friend Mike. And
hey, guys!
Mike is going to act as a rubber ducky and hopefully a live-action rubber ducky which can ask questions and help force me to be honest while explaining this ridiculously complicated thing, because this is going to be a very technical video. So if you're interested in some of the tech behind how Wayward Terran Frontier stores its universe, how it stores the world, and why the hell I've been digging into all that code to rewrite it, because it was written by an idiot apparently, this is what that video is going to be about. And if it's popular, maybe I'll make more of them in the future. And so I've started us here. This is sort of the universe.
Are those galaxies?
Oh, they are pixels. It's a procedural infinite universe, right? And so we've got an algorithm that generates, and you can see actually we've been updating the algorithm, and some of it is not. It's clearly cutting off a star system here. It's supposed to be a procedurally generated infinite universe that generates, star systems. And you see there's a transition there?
Yeah.
What you're seeing initially is you're seeing pixels, because what we're really generating is we're generating an image. And the image has these, so it's this is an image, and we generate the image actually generated on the video card. And we use noise sampling and whatever and math to create what's star systems. We put a yellow dot in the middle, that's a star, and we put red around it, or gray or blue. All the different colors map to different types of systems. And when we're generating the universe, we actually generate it in the form of an image. I should say I generated it because I programmed all this shit. So I wrote an algorithm that samples noise to create a field of little system images, and then what we do, or what the code does is, and the whole idea of the code is that, just like if you were playing Minecraft, as you fly through this universe, when you go to any one of those systems, it then, and you just saw the transition there, right?
Yeah.
What it's doing is, for each one of those pixels, it comes and it it goes to the grid of that pixel, the location of that pixel. It samples, it looks at what the color is, and then it's got a lookup list. It goes and it looks up in the data, which is actually, it's mod data. It's an extension that in theory anyone could write one of these things, but I haven't released sort of the API that you would need to figure out how that worked.
Okay, well, so I can't create one of these yet.
Yeah, but I could teach you how to create one if you wanted to.
It's that simple.
It's not. Well, if it was that simple, then probably people would be doing it. But yes, it is designed with the idea that you could create one of these things, and what's happening is my code goes out to the extension code that someone could write. The extension code then says, here's what you generate for, the three-dimensional representation, the little icons, the glowy things that are going to show up on the map, because this is the map screen. And then, in addition to the map screen, you also have what actually exists in the world, which is, here and here. But I'm talking about the map first, and also about, so this is like our home system. But yeah, so the idea is each one of those pixels gets converted into more complicated stuff procedurally as you get closer to it. And so as you're flying through your universe, first what it does is it'll generate a region. And a region is, you seeing these squares loading in. Each square is a region that's being generated, because it's like, oh, you're looking over here, I might need this, so it generates the region. And so first it generates the region, which just contains all the pixels. Then as you look closer to the pixels, it generates sort of the geometry of just what you would see on this map. But the real process, and the process that I've been working to completely overhaul here, is when you actually take your little ship and fly to a sector of space, how does it take what is literally just a color, it's one pixel from an image, how do you take that one pixel and turn it into the contents of a star system? And then, more importantly, when you're moving at whatever speed or teleporting around the universe, how are those those sectors of the map loaded into an existence when you see them, and then dumped out of existence when you aren't seeing them anymore. And the old system sucked a lot, and it was causing a lot of problems for us, which is why I've rewritten the new system to use a database.
Was that part of the reason why when you would attack a ship, its HP would seem like it would never go down and it'd be invincible?
No, you just made that up. You haven't even played the game.
I have played the game.
This is so. To give you an example here, this is the sort of a handmade map that we have drawn for the home system. This is where like the single player game takes place, and then you can see as I tab over that those pixels become this, but only when you're looking at it on the map, right? So
when you scroll out far enough, that's what it'll look like.
Yeah, those pixels become this. That's the idea, but of our system is to be able to, take the pixels of an image and turn them into the world. So, let's get to the data structures that belie that underneath, though. So the old system that I originally went with, the idea of saving the world, like we were talking about before, is how do you save on the hard disk a infinite procedural world where I can here's an example. Here's the system that I'm in right now, and this guy, that yellow thing, gold thing, is the station that I'm actually on. I have items in my inventory, and on this station I can go to a cargo bay, and I can put my fire extinguisher in that cargo bay. And now, if I go flying, from that station in that system to a point infinitely far away, and then I come back, that cargo bay is still going to have my fire extinguisher in it.
Theoretically.
Well, it's worked. It's always worked. It's worked from the beginning. It
just used a whole bunch of data, right?
Well, so the old system of saving, the old system of saving the entire universe is that we had the universe is on a grid here, and I created a data structure for every single grid. So I had
wait. So every square, you saved it.
Yes, and I defined in my code. This is sort of the naive approach of how am I going to create an infinite universe. You think, okay, well obviously you can't store an infinite universe on a hard drive because a hard drive isn't infinite. So let's start with an empty universe because that's zero data. You don't have to store zero data on a hard drive, and then you generate it as you look at it, so it only stores the things you've looked at. So, naive approach, I thought, well, it's an object-oriented programming language. Let's create a class, and let's call it grid data, and let's have it represent the contents of a grid. And I drew a really terrible diagram here. But my idea was, so you have the terrains, like the asteroids in a star system, right?
Yeah.
And you can bump into those. Obviously, those have to generate. So I in my mind, I drew a box and I said, okay, so part of grid data is we're gonna have like a binary file representing the terrain, and so in my head I was, here's this class, and somewhere in there is going to be all the ones and zeros representing the asteroids in that segment of the map, and so. There's a lot of little interactions, right? Like when you bump into an asteroid, it's got to check all the pixels, and so it's got to know all the pixels of every piece of terrain, and that's a lot of data. So in my head, I'm just placing this data from all these terrain items in this abstract container that I'm calling grid data, and same thing with stations. There's space stations in that spread out through that sector, and the space stations inside of them will have cargo bays.
Yep.
And so I'm creating a box in my head called grid data, and I'm just taking all of the stuff that's in a grid data and I'm storing the idea of that stuff in the box. So I've created one for stations, one for icons, all the little icons that you see on the map here. For all the different trade stations. I'm like, okay, well if it's in that box, because we got to store an infinite amount of these. So yeah. I'm thinking I can't just have like one class that says, here, this class represents the whole universe, and then have all of the icons just in that class, because then potentially you have an infinite number of icons in memory in one class. You have world, list of icons, infinite number, can't actually store infinity. So
So what you're doing is you're storing each class in a separate folder.
kind of, and that was in fact, it was literally a folder. The idea was, when I originally envisioned it, the idea was I take all the things in the universe which have the property of existing in a specific location of space, and I'll force them to live inside of boxes, and then the whole box can be represented as a folder on the hard drive, and when you're looking at it, there's a thread on the processor that goes and loads it into memory so that when you look at it, it's there. And when you stop looking at it, the thread on the hard drive says, okay, you don't need it anymore, and puts it back on the hard drive. And that way, the memory that you have for the game is 2 gigs anywhere. Some people have 64 gig computers, but realistically you have 2 gigs of RAM on a computer if you want to account for really old crummy computers. Much less than that if you want to account for really computers that shouldn't be playing this game, probably. But the hard drive space is, from a programmer's perspective, effectively infinite. And so, yeah, everything you aren't looking at, it's stored in this box and it goes on the hard drive. And that was the old design, is, every time you would move from across the universe, you'd get to the edge of the sector, and it would happen one of 2 ways. A, you'd go across the edge of the sector, and the world would then receive a request for the new sector, and that would just trigger, okay, stop the whole game, go out to the generation algorithm, look up that 1 pixel of color that I showed you from before from the map.
Yeah.
Based on the pixel of color, look into a lookup table that tells you what type of sector to generate from that 1 pixel of color, and then using the process from the lookup table, generate terrain, generate stations, generate anything that would be in the sector, and then and it's a long process, because then you have to go to faction code, right? Because there's factions in the universe. There's the Seven Stars Coalition, and there's the pirates, and there's you see all these little ships flying around. They're owned by all the different factions. And some of the factions, you can see actually these stations, the economic stations, they aren't part of the world, they are put into the world by the factions. So a faction might have a trade station in one of the sectors of space, and that trade station is placed there when the world generates that sector of space. The step after generating that sector of space is the world goes to the faction and says, hey, this section of space has just started existing. Would you have had a station here? Because the player is looking now and it needs to exist. And so at that point, the faction code says, oh yes, I would have had, a trade station and a mining station and a repair station, and here's the locations of them. And so, and all of this is happening basically instantly as the player is transitioning across the border. Well, there's, when you really get into the dirt of what that's doing, a space station is a big data structure, right? You saw the inside of the station. You've got all sorts of stuff here. So, and it's, in order to create it, it's got to put it into memory, which means that every pixel, every single tile of the inside of the station has to go through your computer processor. It has to be you have to march through all the pixels of the various maps of the station and generate the whole interior. It just, computers work really fast, but when you have to touch every single pixel of every single space station that's going into a session, it takes a long time. And so what the player would see when they transition from one sector to another is a very visible stuttering of the program. It would just stop, and the world would have to go through every single pixel of every single space station in order to get it all into the system.
Is that why sometimes when you would switch systems, it looks like it would start populating as you're transitioning into it?
So what you see in the more modern code, when you go into a system, you see stuff populating over time. Well, actually, I think what you saw was in the multiplayer.
Yes.
And that works even different from all of this. That's a whole other video. But what you're seeing in multiplayer is you're seeing the contents of that sector after it has been generated are then streamed to your computer, and so you see them popping in as they're streamed to you. But for this video, I'm only talking about single player, and so if you think it's all on one computer now, it's not being streamed over the network. So when you go into that system, it's all generated. It was all generated at once. I'm talking now very, very early design, because I've iterated over. That's a problem. You don't want people to get stuck at the edge and it's essentially a loading screen without a loading screen. The whole game freezes. It's very jarring to the gameplay experience. So
it breaks immersion.
Yeah, it breaks immersion. Well, so, how do other games handle it? There's lots of games out there with an infinite map, and generally speaking, what you do is you divide your world into chunks, and then you have a thread that's asynchronously creating chunks. And Minecraft is the great example, because that's how Minecraft does it. You are here, and the chunk generator is like, oh, well, I better generate these chunks. And so it's off in the background, and it's doing every single pixel of every single space station of over here, and then it puts it in memory, and it just stores it, so that when you jump over the edge, it's not actually having to generate all that, it's already got it.
So it stores everything 1 or 2 grids over.
Yeah, so what you get is, as you move around the universe, you've got sort of a halo of loaded sectors around you that's sort of being updated in real time. As you move, new ones pop in and old ones drop off. And that's the idea. In fact, and the version that people have that they can play on Steam right now, that's how it works, is each sector is a box that stores these things, and as they move towards a sector, if the box doesn't exist, it is created from scratch, and if it does exist, it's loaded off the hard drive. Problem is, it turns out that that's a terrible way to do it.
Is that because, like, you bring up Minecraft, now is that because if you change the terrain, or if you leave an item somewhere, and you leave that place, and then you come back, it has to stay the same, right? It has to look the same, and everything that you left there has to be there? Is that what you're saying?
Actually, surprisingly, that's not the problem. This system with this box is designed to solve that problem specifically. And in theory, this system is a correct solution for that problem. But what we're trying to do here is something that Minecraft doesn't do. And maybe it's obvious if you look at these ships. They are supposed to be moving right now, although I'm not sure if I've broken the code. This is the new version of the code, and it might be broken. They're moving very slowly. And there's a lot of them. And the reason I chose this view is so that you could see all the different ships. Because this is something that Minecraft doesn't do. You have the world that generates in chunks, and you save the contents, you save the blocks, and you save the items. And there's towns in Minecraft, To my knowledge, I haven't played in a while, I don't think villagers in those towns are doing anything when you aren't looking at them. If you leave, the town degenerates, it goes onto the hard drive, right? Well, if you want those villagers to trade items with other nearby towns, and to go walking along the road, and to fly, and, dropping the Minecraft analogy here, we've got ships flying, between trade stations. Here's a refinery, here's a goods factory, here's an industrial factory. What we're trying to do is we're trying to simulate an economy. So we want a ship that is like
So you just turn into Sim City.
Well, even Sim City has trouble doing that, right? Because they abstract it. You simulate your city, and now I'm going to get myself in trouble talking about... I'm going to get myself in trouble talking about a version of SimCity that I haven't played, but from my understanding, they simulate your city, but then at the edge of the city, everything else is an abstraction. You don't actually know what the other person's city is doing, because they might be a real player over the internet, or they might be a virtual city where all it's actually simulating are the numbers, so that you can see it sort of at the edge. But we have this thing where when you fly in a ship, over the edge into the other area, this ship, which is doing a trade run between two different stations, has to turn into a real ship that you can actually go and encounter that ship. And then when you find that ship, if he's running if he's running a bunch of food from a farm to a habitat, when you find that ship, its cargo bay is going to be full of food. So we need to be able to keep track of, hey, this guy bought food and filled up his cargo bay, but I just told you that his cargo bay is stored on the hard drive, right? So how do you access it? How do you unpack it? Here's ships. And this is like an archive. This is like a zip archive. You can't just go into that file and read just the cargo bay of just the ship. Like, you have to take the entire thing. It's one file, load it off the disk, decompress it, and then you've got all of the ships, and then you can check the cargo bay of that one ship.
It's almost like you're not just trying to generate a world for one player, you're generating a world for an entire civilization.
Well, yeah, and I'm trying to update it in real time. So basically, I took a data structure that was perfect for a infinite world, and then I tried to do things that, well, perfect for an infinite world in a different game. And then I tried to do things that game specifically avoided doing because it's so difficult to do on that data structure. And so I painted myself into a corner. And the reason is this. You see ships like this guy is transitioning from one sector to another. He's in the process of flying from one sector to another. Well, what happens when he flies from one sector to another? But I've already written this sector to disk, which says the ship is in that sector.
You have to rewrite the whole thing, huh?
Oh, well, so that's exactly the first problem that I run into. So I'm like, okay, well, so ships are kind of not in that data structure. They're actually kind of in memory, and they only go to that data structure, when I save the game. Okay, so here's our first exception to the rule. We've started, you see how I've come up with this idea of this rule to save the whole universe, and
so instead of square ships, you have oval ships.
Yeah, we'll use oval to represent, square to represent how I thought it was going to work, oval to represent how it kind of actually works. I think that's perfect.
Yeah, that works.
Because we're going to have ovals all over the freaking place by the end of this video, I think. Let's make our next oval right now. Backdrop info. Turns out, originally when I had this whole system drawn out in my diagram, I was like, well, the backdrop info, when you go there, you generate it and then you save it. Well, it turns out you don't have to interact with it anyway. You can't ever change it. You talk about, like, you go in Minecraft, you change a block, you come back, you want to see the change to, well, you can't interact with the backdrop. So why the heck are you storing it? So
it should always just be there.
Yeah, so screw storing the backdrop info. Let's just regenerate it every time. Okay, cool. So, so now ships are, they're stored in the grid data, but only sort of when the game saves. They don't actually live there. Most of their time is now spent. In other memory.
Okay, so this brings up a question I just had. So sorry to interrupt.
No, that's good.
You say that with the backdrop info, the oval backdrop. It reminded me of No Man's Sky.
Yeah, where they generate everything as you go to it.
Yeah, and you go to a new one, and then you go back to the sector you just came from, and it's a completely different sector.
Yeah, so when I'm saying backdrop info, you're thinking, I'm not talking about the actual stations that you interact with, or the mining nodes, or any of that. I'm talking about literally the skybox, just sort of literally the backdrop.
Oh, okay, so the background, yeah.
Yeah, the background. Yeah. And since it's visuals only, it's generally pretty safe to just regenerate it every time you go to it. You don't have to store it. I'm guessing No Man's Sky does the same thing. Like, sure, the planet, it's got to be stored somehow, but the actual skybox, they don't write that to disk. Yeah. So on my diagram, here we go. Backdrops is out now. Well, data and icons, that's actually a winner. Totally lives on the grid. Except, well, look, I can see the whole universe on this screen, and I gotta be able to see all the icons. But they're all stored in these boxes. So what do? I have to iterate through every single box? Because every single one of these grids, you see the grid here, and these are all supposed to represent folders on my hard drive. But I'm trying to draw it 60 times a second, so am I taking every single icon out of the hard drive, every single, 60 times a second? No, you can't do that. You can't do that 60 times a second.
Well, and that brings up another question. You say the NPCs, continue to move while you're not looking at them. Does that also mean that the factions space stations, the faxing trading routes, do those also change?
So the contents of these stations, as you can see, there's little bars tracking their resources. So they have a simulation running in memory all the time. They know what resources they have, what they use. Their crew should be eating food in theory, and they consume some resources to produce others. It's an abstracted simulation, but it's got to be in memory. It can't be on the hard drive. So right there, again, kind of, I guess I'm going to have to draw another oval, because while data and icons are stored on the hard drive, they aren't technically on the hard drive during the simulation. Like, when you fly away from that sector, you have to leave data and icons in the memory. When you're saving grid data to the hard drive, you can't save data and icons because you got to keep thinking about them. So man, so what's left? Stations and terrain. Well, here now we're finally to the point where stations and terrain actually legitimately, what we're talking about when I say stations and terrain, I mean the actual data structure that represents the ship, in the ship interior, the shape of the ship, the image of the ship, and I'm saying ship when I mean station. They're essentially the same data structure. It's the interior of something that your crew can walk around inside of, all the modules and such, and that actually takes up a significant amount of memory, and it's immobile, which means you can't see it when you're outside of the sector. So that absolutely can be stored on the hard drive, and terrain, which is all of those asteroids and such, those can live on the hard drive too. But unfortunately, I'm gonna have to draw another bubble here, because terrain is a kind of a so stations worked out the way I thought it would. Stations get legit saved to the disk. When you fly away from a sector, that grid data box saves stations to the disk. It also saves terrain to the disk, but as it turns out, all those pixels of the terrain, they don't change. They actually come from textures. And the types of asteroid art asset that we use for those terrain items are used in every sector. So you're looking at this sector, and you go to the next sector, you unload the terrain art, but then you reload the same exact terrain art in the next sector. So it doesn't make sense to store them on the hard drive and to store a copy of them for every sector. So we ended up building a whole abstraction system for terrain, whereby the terrain art, the art of itself, the actual pixels, lives in separate memory, and then all we really store of the terrain is a little tiny binary file that represents where we place those art items. Right, so when I created this, I thought, okay, it's going to be this huge terrain, is going to be all sorts of big station things, big things you can interact with. It's going to be a lot of data. Now, ends up being that terrain is actually, you can think of it as like this tiny little fraction of what I thought it was going to be is written to the disk, and literally everything else of the terrain is just in memory all the time. So my design was terrible because of the things that have to move around in the world, and so it got very confusing keeping track of all the different rules of when you entered a system. The ships were already in memory, so you didn't do anything. The backdrop information loaded no matter what, so you didn't even have to check this connection. The icons were in memory already, and so nothing had to happen. So stations had to be loaded off of the disk, and terrain had to be loaded off the disk. But after terrain got loaded off the disk, you had to actually generate the terrain with the art asset, and more importantly, if you had already been to the system before, terrain loaded from the disk, but otherwise it was generated. And if you had already been to the system, same with stations, same with icons, same with ships to a degree, actually, because ships would spawn when you go into a system. So everything had its own rules for what it had to do when you entered a system, for what it had to do when you left a system, for what it had to do when you when you re-entered a system that had already been stored on the hard drive, and there were different rules for what gets written to the disk and when it gets written to the disk. And then here's the interesting part: you click the save game button because you want to save and exit the game. Every portion of this is in a different part of memory. How do we get it all together into this grid data structure so that it can be stored? And that's why our save game process takes fucking forever, is because what we're doing is we're going out and finding all the ships and shoving them into this box that never should have been made for them, and then taking all of the boxes and writing each of them to their own little folder.
And so what you're saying is it would save the exact location at that point in time where the ships were? Is that why?
It would take everything. The position of every crew member inside the ship, every pixel of every ship, and the damage of that pixel would all be written to an intermediary binary format. Then all the intermediary binary formats would be shoved into the grid data structure, and then the entire grid data structure would be written to disk in a folder. And here's where a lot of this is the source of the bug that got a lot of our quests screwed up, is that we use, because when you're moving around on the world and you go from one sector to another sector, you want that sector to be preloaded so that you can just, like we talked about earlier, you have a thread going around. Yeah. Well, the problem is that means that all of this complexity, all of these different confusing little steps that can happen, are being done in a separate thread from the thread where you clicked save game. So when you click save game, it has to resolve with this huge mess of all these different things going on. It has to resolve, okay, what step of that process is it in, and how do we finish it so that we can reverse the whole process and save everything. And what was happening for a lot of people is, they'd go down to, this is a famous quest, down here, there's a big complex, and there's a guy that spawns in this complex that you have to kill. His name is Bud. And Bud has a very bad habit of, people would fly to Pirates Cove, which doesn't generate Bud, and then they'd go over a system and that generates Bud, and then they'd enter the system, whether getting near it or entering it is a question. How's that going to happen? If they go really fast, they enter it before the thread gets to generating it, in which case the main thread generates that sector. If they go slow, the pre-generation thread generates that sector. And the pre-generation thread and the main thread have to negotiate on whether or not that sector exists, because when they enter that sector, Bud is going to exist there. That actually usually works itself out. Bud is usually there, but if they don't agree, Bud will sometimes spawn at position 00, which is off this way somewhere. And so you can see the player will be like, where the heck is this guy? And he's like off in the oh yeah, in fact I think it's happened. It
just happened?
Well, this isn't a surprise. A lot of things have been welcome to 00, where things end up when you don't initialize them properly. But no, this is exactly what was happening before, but this isn't a good example now, because this is happening right now because I've rewritten everything and I haven't debugged it yet, which means that my new system, which hasn't been debugged, is experiencing the same issue as my old system after years of debugging. The old system, because of all that ridiculous complexity, would often disagree about whether or not something had been generated and just lose it. It would be gone. And so there were a lot of people who complained that because part of the quest, the main quest, is you got to kill that guy Bud, well, he would either generate down at 00, or this sector of the map would generate, and then the save game would come along and not catch that sector because it was in the process of generating in another thread, or it would save a version of the world that contained not Bud, and then when you reloaded the game, the save game didn't have Bud. And so it was like, well, you can't complete the quest because the guy that you need to kill doesn't exist. Although, honestly, more often the reason is Bud had actually spawned way down at 00. The reason he spawned at 00 is because his spawn location is set by the faction code. Mm-hmm. And I told you when you're generating up the session, faction code is like one of the last step.
Yeah.
But you only want that step to happen if the sector has not already... if this is the first time the sector is being generated. Well, so what happens if you have a thread generating the sector, and then the main thread comes in and generates the sector, and the faction code says, oh, well, that thread already generated the faction code, so I'm not going to place the... Well, it gets confusing, and the point is it's supposed to work. It didn't work. It obviously doesn't work, because a lot of people complain about the quest not working. And my own code is so goddamn complex, I can't even figure out where the hell it's being lost. It's being lost in... I don't even know. I don't know. Where the hell did Bud go? I don't know. So, he went to 0-0. I know where he went to. Why? We've been looking through the code forever to try and figure it out.
And it's just mystery.
Well, and the answer that I came to is that, this whole garbage right here is the reason Bud ends up at 0-0. And so the solution is not to try and find where in this process it's messed up, but to realize that literally every single part of this design has failed me, and it needs to be thrown out and replaced by something new.
Something that actually works.
Yeah. And not files in folders on your hard drive. It should be a database. And this is the big fundamental problem of a world that it's a living world. I have portions of the universe which are on the hard drive and portions of the universe which are not on the hard drive. And here's an example, because this sector right here, right now, not on the hard drive. I'm in this sector. It's got real ships. Other portions, just a couple sectors away, are on the hard drive, and it's got to be seamless. The idea of saving the entire world as a single set of files on your disk that preserves sort of the orientation of everything in the world, the state at a point in time, all saved at once, is a terrible idea when the world is infinite and there's things moving around all the time. And so I never should have tried to put everything inside of a sector in a box. Instead, what I should have done is I should have created a database, and I should have looked to see which stuff actually should go to the hard drive and which stuff should stay in memory. And ships are a great example, because I said ships didn't work out the way I thought. Well, a ship has a lot of data, because a ship is an image, and you have to store every pixel of the image. And in order to render it, those pixels have to be in the video memory. But when it's off screen, you don't need any of those pixels to be in regular memory. And my old system failed on both counts, because not only could those pixels not be on the hard drive because I needed the ship to move around, but all of the pixels of every ship were in the memory because I was moving them around. So really what I needed to do was I needed to store the pixels of the ship on the hard drive, and then keep a representation. I call it a puppet. Mm-hmm. I keep a representation of the idea of a ship, and I move that around on the map. That's what you're seeing here.
So that's the red dot is the puppet.
So the red dots are puppets. It's not a real ship in that it doesn't have all the pixels, it doesn't have all the crew, it's not running the little interior simulation of the ship. But it knows everything it needs to know, so that when I look at that individual ship, the actual interior of the ship can be loaded from the hard drive, which is what takes up all the data, right? When we were trying to draw this diagram here of what all is going to be on the hard drive, all of this stuff ended up not being properly in this box because all of this stuff has to live in memory. But what stuff is there that actually can live on the hard drive? Let's draw some more ovals. A ship, all of its pixels can live on the hard drive. Backdrop info we're going to ignore. Data and icons. Data and icons are interesting because they don't change very often. So you can write them to the hard drive and keep them in memory. And then if they get accidentally deleted, like is in the case with the Bud Quest, doesn't matter because they never change. His spawn location shouldn't be changing in real time. If you lose it in memory, if someone Alt F4 as the game closes, the power goes out, well, it should still be on the hard drive. You should be able to load it back up, right? That's how it works in the new system in the database. because I write the icons to the database, and then when I look at a sector, I load them out of the database, but I leave them in the database.
So they stay there. They don't get like cut out.
Yeah, and same with terrain. Sure, it's much less data than I thought, but the terrain also. So basically, and the most important part of all this is that it has to be multi-threaded. Like it's got to be, it's an infinite amount of data. We got to do it in multiple threads. So really, I like this diagram. You can see what I drew here. These are my threads.
I see a face.
Oh, you see a face?
Yeah.
Okay. Well, I drew this diagram to represent the threads, the important threads of my game, so that I could explain. So a thread is a thing that a processor core is doing in real time, and threads are like quantum objects. They, if they interact with each other, which is to say, if they share any form of data, they get entangled with each other and they go slower. So you don't want threads to touch each other. You don't want any data item messed with in this. So I'm drawing a loop here to represent, because all of my threads are loops, right? They're just, so when you're writing code, you like while some condition do other thing, and it just continuously does that thing, right? And really the structure of a video game is just a big loop. It's you tell the video game while the video game is running, here's a list of things to do, and you do them over and over and over again, right?
Yeah.
So everyone knows that for like a frame rate counter at the top of their screen when they're playing a video game. The frame rate counter is just counting how many times each second do I go through my to-do list. So you might have on your, so here's on the bottom is my main game thread.
Right.
And a lot of games, honestly, will only have the main thread because that's all you really need for most games. So your first thing that comes off of this will be, check all the keys on the keyboard to see what buttons the user is pushing. So, that's your main game loop does that, and then it goes along and it's a loop, so it's going all the way around. And it's going to do all this again. But now maybe before it does that, it checks to see how much time has passed. So it checks how much time has passed, and then it checks the keyboard, and then it goes on. It goes on to the next step, and it checks to see, okay, what screen am I on, right? Okay, so do the logic of whatever screen I'm on, and different screen is going to have different logic, so it might be a loop itself, but it'll always come back and it'll always finish the main loop. In our game, the screen logic is a loop, and the world logic is a loop that are all on the main thread. Okay. So all this stuff that is moving around here, because the player and what they see, because over here on the loop, of course, is always going to be render the game. This part of it is always take whatever data you have and put it onto your monitor so that the player can tell what the heck is going on. And so over here you have the data for the stuff in the world moving around, and over here you have the code to draw the stuff in the world. Because it's on the same thread, that data, the same thread has no trouble accessing that data because it's only changed by this thread. It's always deterministic. Mm-hmm. Here, it's predictable. It's safe.
It all goes in order.
Yeah.
And then the last circle is the final check before it repeats.
Yeah, and then you get here and you just go back over to here again. And so 60 times a second, you're going to draw 60 times a second. You're going to update the position of ships on the map 60 times a second. You're going to do whatever logic is special to the screen that you're on 60 times a second. You're going to check the keyboard 60 times a second. Cool. Over here is our thread that's like in the background trying to generate the world. Maybe over here it checks, you're kind of near this sector, I should load it. And it starts running the routine to generate a new portion of the map. And over here, it's, doing something else. That's the main thing it does. This is the world, though. What I've in the old design, I tried to put all of this stuff into that. And then I realized that I interacted with all of them, right?
And so since it had to run everything in order,
Everything in the box is what I thought everything in the box is what I thought was gonna be in there, so I put it in there.
mm-hmm.
But everything in the circle ended up being over here somewhere. So what we ended up with was all sorts of interactions between threads.
which slowed it all down.
And not only did it slow it down, but it caused potential bugs, right? Because if this thread is at, this junction and it's doing something that touches this piece of data, while this thread is also at that junction, it can read it in a partially modified state and get corrupt data. And so that is where Bud disappears. And there was enough of these that, where does Bud disappear? How does Bud disappear? I don't know, because it's really impossible to you've got a live flowing system here, and this is all happening 60 times a second. It's really hard to catch it in the act in a testing environment of the stars aligning and those two things happening at the same time. You can't it's hard to make a breakpoint for that. So the way I redesigned it is I said, okay, let's take a look at what actually needs to talk to the hard drive and what actually needs to be in memory, and then let's mediate that red line there. Let's mediate that with a data structure that actually handles the concurrency, as in we have, and we'll make blue will be the new stuff. Here's my database, and it's on the hard drive. And this loop comes along, and it's got one job. And all it does is it's in charge of talking to the database and getting stuff from the database, or, return... I guess that should be putting stuff into the database, reading stuff out of the database. Like, this thread, that's all it does. Which is a much better design than trying to do the whole update thingamajig in that thread, because really the whole update thingamajig, it should have all just been over here to begin with. It should have been in the main thread, because it's not actually, remember this, where I said the terrain is huge. Moving stuff in memory takes a long time. Oh, but the part of the terrain that is actually dealt with in memory is tiny. So tiny is fast. You can do tiny fast. That means if you put something tiny in the main thread, it doesn't matter. So having all of the terrain in the main game thread actually wasn't a problem. It was having the art assets of the terrain in the main game thread is a problem, because the art assets...
Those are the big part.
It's the rest of that box, and it's heavy. It takes a lot of time in that loop. And so what should have been is art assets should have been over here, terrain should have been over here. But instead I had it all mixed up, the red lines, mixed up. So I created a new paradigm that's simple. The database is just a list of everything in the universe that it's aware of. It keeps track of what it is, where it is, how long it's been unseen for, and all the binary data for it. And then as the world goes along with its simulation, at the boundary condition of the player, we got a loop here of the player moving from one sector to another sector. That's part of the update loop. So that'll be in the world update code. So somewhere along this loop, it's going to say, oh, the player's at a boundary condition. Let's check to see what they should see in this new session. And, well, as it turns out, when you go into a new session, instead of stopping and loading the whole goddamn session and having the game freeze, you can just create an empty session. You can just say, okay, congratulations, you're in a... I want to have a square for this. Okay, here's your new session. You're in it now. Done. And that's, the main game thread is, okay, I'm in that new session. It's an empty box. It doesn't actually take any time for this code to create an empty box. You're not partitioning any memory. There's nothing there. You're just in an empty box. So the player will fly into a new session. They got their new coordinate system, so they could just fly around just fine. But there's nothing there. It's black. There's no ships. There's no stations. There's nothing. But this guy's working in another thread. And one of the things that you did over here is when you entered that session is you created a whole lot of requests. And those requests, they're gonna go to what I created is an intermediary object that receives the requests like a message. It's like a network message. It says, "Hey, I just generated a session. I need the contents of that session, please. And the database, oh, I know how to do that, right? Because in the database, it's got stored, session. It's got that session. It's got all the things that are in that session. And so the database then, in its own time, is going to go and say, okay, well, every ship, get one ship. Oh, and ships are going to come out one at a time, one at a time. Well, every time one of those ships comes out of the database, it just drops it into that little thing, and then this loop, the next time this loop's coming around, it's going to check that mailbox. So he's going to come out here and he's going to check the mailbox. Oh, hey, there's a ship. I got one of the ships. So, all he does is he moves the ship over to a session. The player, he sees a ship show up in his session now. There's a ship, right? Well, this is happening so fast that this is going to take place over a couple seconds. So now, instead of seeing the game completely freeze for a couple of seconds, what you see is,
things start to populate.
Well, the backdrop has already preloaded before you get there. So as you go over the edge of the session, you're still seeing the full backdrop transition is seamless. There's no visible lag. You get into the new session, and the terrain, because you were in the old session, you couldn't have even seen that anyways. You get to pan your camera over there. Well, probably in the time it takes you to pan your camera over there, you've already got, because remember we mentioned terrain actually isn't that big. Yeah. This tiny little thing is all that you need to load from the database, so that goes really fast. So within a couple frames of animation, you've got that, and then all of the rest of that is always in memory. It's those textures representing the asteroids. Those are already in memory too. So the main loop is just perfectly happy to, oh, hey, got the, once again, it goes along, it checks its messages. Oh, there's the train. And it goes, and part of its little loop now is it's got this little loop here that all it does is it takes from video memory all those textures and it puts them into the session, and then, oh, look, now you've got all your train. And that's almost instantaneous as far as the player is concerned, and there's no slowdown at all. And so, and then, of course, when the player leaves this session, they go outside of the session, all this stuff needs to get stored on the disk again. Well, no need for the main loop to deal with that. The whole damn session just gets dumped right into the database. And the database can handle it in its time. Because the database is transactional, if you then turn around and go back to that session and say, wait a minute, I changed my mind, I actually do want to be in that session, the database has rules. It says, first the thing goes in, then the thing comes out. And because it's transactional like that, it's really simple rules to keep track of. Bud goes into the database, Bud comes out of the database. It's 2 steps. It may take a little bit longer, but that's what you get for being indecisive. And bam, look, Bud wasn't deleted, nor was he spawned on the wrong side of the universe.
Doesn't go to 0-0.
Doesn't go to 0-0. So that's the idea, this ridiculous image now, of what I had to do. But of course, I mean, this code is tied into every single piece of the program. I mean, every ship that moves has to move in consideration of all the rules of how the ship is loaded and stored as it moves. So it's a huge rewrite, and that's what I've been doing for months.
It's a lot of code to rewrite.
Yep. And I got it working like yesterday, kind of. I mean, as you can see, kind of is in the sense that it's dumping stuff at 0-0.
Yeah.
And it's I can't save the game. Not that I can't save the game, but that I haven't written the little bit of UI code to actually save it correctly, so it tries to save it using the old method, which of course crashes.
So how does that save? What is it, all to the hard drive instead of some to memory?
So that's the thing, though. So the nice thing about using a database is that a relational database is designed to solve this exact problem. When computers were invented, people had stuff in their programs that they needed to put out to the hard drive because the hard drive's the only thing that still exists when the power goes off. So the original system for storing data on a computer was always like, put it in a box, write it to the disk as a file. And they, over time, people came into the same exact problem that I've had, which is, oh, well, I want this on the hard disk, but sometimes I need to access a little part of it. Or, oh, I want that on the hard disk, but I often have to access a little part of it. So the big file that gets stored all at once on the hard drive it over time gets broken up into little files that, maybe you store these as, as separate files. So when you want to access the storage of a ship, you only have to load one file instead of the whole thing. You see how that's an optimization? Yeah. Okay, well, so what's the next optimization? Well, maybe save the ship separate from its inventory. Right, so the file that you will need to load is only the file of the cargo space of the ship.
So it's folders upon subfolders upon subfolders.
Yeah, you start thinking of you make smaller and smaller files so that you can access more precisely exactly what you need, and then eventually someone comes along and says, "Hey, why don't we write a language called query language that will use..."
Is that SQL?
That's what SQL is. It's a language that is literally the ultimate abstraction of the endpoint of this smaller and smaller file thing. It's this idea of, hey, we have all this data. Let's just store the data in a continuous state of kind of on the disk and kind of not on the disk, and have a program abstract for us whether or not it's on the disk. And then when we want the data, we specify what we want with a language, that's SQL, and the program just keeps track of getting it for us, and then also making sure it's on the hard drive, so that when the power goes out, all of our data is just still there. But you see, by doing it that way, you've taken the step of writing everything to the disk and turned it into such an infinitesimally small step that there's never any need for at any point there's never a need for a screen that says saving, where you have to sit and watch for an hour while it writes the whole damn thing to the hard drive.
So it's like with terrain, right? So when your data structure, right?
Yeah.
What you're saying is you keep putting terrain in folders, subfolder, and then you need a rock. So instead of rewriting and pulling the entire terrain subfolder, you can go to the rock subfolder and just get a rock.
Yeah, because what the database is doing is, instead of taking the whole section on the map and storing it as one zip archive, it's got a big table, like a spreadsheet table, and in that table is all the rocks. And the rocks are all indexed. So you can request the specific rock, and it goes to the table for that rock, and it's here's that rock.
Rock 3 millimeters by 3 millimeters.
And even more so, it gives you power to do things like, this system over here is not fully in memory. It's actually mostly on the disk, because I haven't looked at it in a long time. But if this ship goes to something in there and it wants to make a trade, it wants to change something, maybe it wants to pick up a rock and put it in its inventory, I don't have to load the whole sector. I can tell the database, take that rock and delete it, take that ship, open its database and add a rock.
And then save it to hard drive.
And it's an SQL statement, so it's automatically on the hard drive once the SQL statement is completed. And so you don't have to worry at any point. The only thing you have to do is, before you allow the program to exit, you tell the database, okay, I'm done with the database. Please make sure everything's on the hard drive now. And databases are pretty good because...
And that makes it a lot faster to save, right?
Yeah. In theory, with this system, when you exit the game, it'll be like, okay, done. And it'll just close, because it's all on the database already. And the only thing it really has to do is any transaction you had just created, like if you had just left a session, that session was already saving to the disk. So when you click exit game, all it's got to do is wait for that last couple of transactions to finish, and then it'll be closed.
And so that's how Bud now should not go to 0, right? Because it's always saved on the hard drive.
That is the hope. That is absolutely the hope. I hope Bud will stay in his goddamn system, and people will be able to kill that guy and get the reward.
You can always just give him a teleportation ring to 0.
Yeah,
fight everything at once.
Certainly, if that's true. I should build a warp gate at location 0 so that players can just... Hell, maybe I'll make a quest out of it and be something.
It's the quote unquote cow level.
Yeah, it'll be my cow level. It'll be the snarky robot will say, well, for some reason, things sometimes show up at this one particular portion of the universe, so we've just decided to make a gate there. That's how you can find anything that's missing.
What's that?
It's like the universe is lost and found.
Yeah, what's that universe called, or that pocket universe in Avengers, where all the garbage goes and the Hulk is there and Thor's there?
Yeah, sure.
Everything just comes here. It just gets dumped here.
Yeah. So that's what 0 is in our game, for obvious reasons, right? Because if something doesn't load properly, all of its data fields are probably zeros. because that's like the default value for any variable. And, if the position data fields are zeros, then what's its position going to be? It's going to be 0. And so when it says to the world, hey, store this thing that I just found whose position is 0, the world, being smart, says, okay, puts it in that box and writes it to the disk. So, yeah, that's the new system. And as you can see, it's still buggy as hell. I don't even know if these ships are moving. They're supposed to be moving.
No, they haven't. I've been watching it. They haven't moved.
Great. So that's another thing that's broken. I literally, as soon as just yesterday, last night, very late last night, I got it to the point where I could even get into the game without it crashing. And so the fact that I was able to get far enough to, see all the different ships was very nice.
Okay, now we're in our Q&A session. I want to ask you this question.
Oh, geez,
It's been
okay.
bugging me the whole time. So scroll all the way out.
Oh, yeah.
So we were talking earlier at breakfast, right? The donut versus the sphere.
Oh, geez.
Right? So this is your entire universe, and you say it's infinite, but what happens if you go all the way north? Will it continue to do it infinitely?
Yeah. Well, I mean, until it hits some edge case that I forgot to account for in my code. Because, well, infinitely, right? You always have to say infinitely in air quotes.
Yeah.
What's really constraining it? Well, so you see these things are generating. We know those are grids.
Yes.
Grids have a coordinate system inside of them, which is integers. And a computer can store a very big integer. So a grid can have a lot of coordinates inside of it. But integers are stored using either 32 or 64 bits, which means that the integer does have a max value. So you end up with a maximum x and y coordinate inside each individual grid. But the grids themselves have their own coordinate system, which is also integers. So you have coordinate systems inside coordinate systems. You have nested coordinate systems. There's also a coordinate system inside the individual sector. So the coordinate system inside the sector only goes to maybe 100,000. You go to the next sector, it rolls over to 0 again. So the computer never has to represent a number bigger than 100,000. Because that's really the limitation of computers, is how big of a number can it represent with a certain number of bits. When I say that our universe is infinite, what I mean is that the grids themselves are stored with a coordinate that is integers, and each one of the 1, 2, 3, 4, 5. So, you have a grid coordinate, which is, we're in the center of the universe at the home system, so that's grid coordinate 0, 0. Well, integer.max value, something like 6 million. So I guess when I say infinite, what I really mean is like 6 million of those grids in either the north or south direction before the computer will get an overflow error and everything will just go crazy and probably break. At which point I'm sure everything will go default back to the location 0, 0, and you'll get an infinite amount of universe generating in one sector and the whole game will crash. But, so when I say infinite, what I really mean is unbounded, except by human mortality and the limits of your hardware.
Yeah, I was about to say, I don't think a person playing would ever get to that point.
Correct.
Especially with the time it takes to travel.
Yes, that is the secret, that is the real trick to games with infinite maps, is that you just have to reimagine your definition of what infinite means so as to align the idea of infinite with something that a human is incapable of doing.
It's like if you were to play this game for 100 years, every hour, every day, you'll finally reach it.
My system doesn't generate an infinite world all at once. It just generates it while you're looking at it. So in order to experience an infinite world, you would have to live an infinite amount of time. And I'm cheating. I'm assuming that won't happen.
This is how God must feel.
I guess, yeah. That explains it. As he's sitting up there saying, "Oh, those jerks better not live too long, or they'll find out that I only made the 1-star system."
That's where I got to destroy the universe and create it.
Yep.
Well, so that answers a lot, though.
Yeah. And I'll probably wrap up. Honestly, I think probably that is well beyond the point where we should have wrapped up the video, because that was not a video. That was like a fucking podcast. And, sorry, pardon my language. We talked for a whole hour, and by we, I mean me for the most part. And
I was there for a few minutes.
Yeah. That was an hour and 4 minutes, and my voice is almost gone. So Man, I don't know how often I could do one of those, but if the people like it, I'd be willing to do it. That really should have been a podcast, not a video. And I don't know if I'll ever be able to upload this now. We'll have to see what happens. But I think it was pretty good for a one take. And you know what? If it turns out the audio didn't record for this, although it looks like it is, oh man,
you'd be so fucking mad.
I would be
blank
so
screen
angry.
forever.
Oh, I would that is the point at which I would say, you know what? I decided not to film any videos, and people would just never know that any of this had happened. But anyways, that being said, if you're still here in the video at this point, I hope you enjoyed the technical jargon of how to make an infinite world that isn't actually infinite. And tell me in the comments what you want to hear me talk about next. I'm willing to talk about anything. Hell, I will even rant about politics, but only if you ask me, because I don't want to. That sounds like a terrible idea of a thing that I should not do. Point is, give me topics of things to talk about. And I guess, what do people say? They say like, subscribe,
and share.
And share. Yeah, that's what they say. Oh my god, I probably should have said that before the 1 hour mark. Oh, whatever. Nobody's going to do it anyways.
Everybody skips to the end anyway.
Yep.
Anyway, yep.
Okay, that's the end of the video.